We have a few applications with these definite integrals that I want to cover in this video. The first is something I've been talking about for a while, so I just want to make sure that you're used to the presentation. The second one is kind of an extension of what we've done. So your first connection is we understand that definite integrals are representative of area under a curve or bounded area. So on the AP test, when they ask you to find area, your first thought should be, I got to integrate. And they have to tell you what is that function that we are integrating. So they will present a problem where they actually write your function equation as like a y equals. So that means that we know for sure we are integrating 2x squared minus 3x plus 2. Now, your boundaries of integration will be one of two things. Either it will be presented directly, like this one. It could be presented visually, where they actually show you a graph of it and you can see your boundaries. Or it could be something where they say like where certain things intersect or where certain things cross the x-axis. So there's a variety of ways they can give you the boundaries either directly or somewhat indirectly. So those are my boundaries of integration. And at this point, we are truly just integrating. So I'm going to do this one both by hand and with a calculator just to make sure you're comfortable. So by hand, we have a lot of power rules, 2x to the third over 3 minus 3x to the second over 2 plus 2x, going from 0 to 2. When I put 2 in, 2 cubed is 8 times 2 is 16, so 16 thirds minus when I put 2 in here, I get 3 times 4 is 12, divided by 2 is 6, plus 4. When I put 0 in, I actually get 0. So this is one that they very well could ask you to do it without a calculator because it's not too bad. You end up with 16 thirds minus 2, which is 16 thirds minus 6 thirds, which is 10 thirds. I did graph this on my calculator just so you could see what is your answer representing. So it's representing all of this area under the curve. Calculator, just to remind you the process of that, we go to the math menu and math 9, and we're going to type in our boundaries are 0 to 2. And then our function is, let me move this over so I can see it, 2x squared minus 3x plus 2. Again, make sure we say that we're working in terms of x. And then if you want to write that as a fraction, you can hit math and then fraction button to get 10 thirds. So that's your first application, and it should be very comfortable for you because we've been talking about this all along, this area connection. The second application is finding something called average value of a function. Very, very common AP topic. They tend to ask about it a lot. They're very direct when they ask you to find it. They will actually use the phrasing, find the average value of this function. Some calculus books call it the mean value theorem for integration, which is very confusing because then you confuse it with the mean value theorem. Luckily, the College Board does not do that. They use average value because it is a little less confusing. What average value is it's finding the average height over an interval. So your answer is actually a y value. It's saying over the course of a given interval, how high is this function? So we have a definition for how we find it. Essentially, what you're doing is you're finding the area under the curve because that's what the integral from a to b of f of x is. And then you're dividing it by the width of the interval. That's what b minus a is. So think about it in terms of basic geometry. If I have this curve right here, this function right here that's this curvy function, and I want to know the average height, if I take the area and divide it by the width, think in terms of a rectangle, like area equals length times width. If I know the area, which is the integral, and I know the width, which is the difference between the boundaries, I can divide those two and I will get your length, or in this case, the height of the shape or of the rectangle. So when you get your answer, if you get a positive answer, it is saying that this function is above the x-axis because it has an average height that's positive, or it's more above than it is below. If you get a negative answer, that's telling me that the average height is below the x-axis, meaning it's more below than above. It is possible to get a 0 answer for average height if you have the exact same amount of the function above the axis as you do below the axis. Essentially, what they do is they just cancel each other out. So that's what your answer is looking for, and it very much will be directly stated. What is the average value of this function? Eventually, we're going to be able to do this with more like real life quantities, where they'll give you a function that represents the cost of a particular object, and it will ask for the average cost over a certain time period. So again, you are integrating and then dividing by that width of the interval. So here's how it works in two problems. They will give you the function, they will give you the interval, and then they will say in some way or shape or form, find the average value of this function. So you are integrating it from start to finish, so from 1 to 4. And then whatever answer I get, that my answer will be area, I'm going to divide it by the width of the interval, which my interval is 3 units long because it goes from 1 to 4. I usually write it like that. I usually don't put the in front of the integral. I put the whole big division bar just to remind me that I'm dividing by the width. So when I integrate that, I get x cubed minus x squared going from 1 to 4. So 4 cubed is 64 minus 4 squared is 16. 1 cubed is 1, minus 1 squared is also 1, so that's going to be gone. So I end up getting 48. So that's the area under the curve of 3x squared minus 2x from 1 to 4. My interval is 3 units wide, so that means my average height is 16. That does represent a y value because it's the average height of the function over that interval. Next one, I'm going to do this one entirely with the calculator just because it's messy and to show you what the calculator actually does for you. So we are going from 0 to 2 and integrating x minus 2 root x. Notice I could not work with negative numbers here because of the square root. Whatever answer I get, I'm going to divide it by 2. So I'm going to go to my calculator, come over here, and I'm going to do math 9, and I'm going to type in my boundaries. I'm going to type in my function that I want to integrate. You could use the 1/2 power or just the square root. I think a lot of times the square root's a little easier to type in. You are going to get a decimal, mainly because of that square root. Square roots often produce things that aren't very clean when it comes to answers. That is your average area, or that is your area. Now you'll notice it's negative. That's telling me about the location of the area. If I divide by 2, my average value or my average height is negative 0.885 or negative 0.886. They would accept either one. What that means is my function from the interval 0 to 2 is actually more under the x-axis than it is above the x-axis. So negative answers are okay. They are just indicative of location.